Okay, so this will be our triangle congruence SBW. I'd ask that you pause the video for a moment and see if you can come up with the correct reason why the two triangles are congruent. Okay, you should have selected angle, side, angle. You can see that you have an angle, an included side, and an angle, an angle, an included side, and an angle. So angle, side, angle is the justification for why they're congruent. By the end of class, you're going to be able to, once again, write congruent statements for congruent triangles, determine a postulate or theorem that proves the triangles are congruent, and again, we're really kind of utilizing all of them now that we've seen thus far. And of course, we're avoiding the one that we know is not, right? Side-side angle is not a postulate or theorem. So we're going to review the postulates or theorems. We're going to review the meanings. Specifically, we're going to look at real-world example problems, and then you have your SBW. So in reviewing the postulates, we have the 5 that we've seen: side, 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 angle, side, side, angle, side, and of course the hypotenuse leg. So now, what you're definitely going to want to do in the following slide is take a screenshot of this particular slide because you're going to need it for your SBW. So please take a screenshot of this particular slide so that you have it ready for your SBW. Maybe take a moment now to do that. As you're doing that, just to think about the 3 of them that we need, remember you have side, 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 so 3 corresponding sides are congruent. Side, angle, side, 2 corresponding sides are congruent, and an included angle pair. And then hypotenuse leg, you have to have 2 right triangles, and you have to have a hypotenuse pair and a leg pair congruent in order to use that. Of course, we can't forget about the other 2 that we also talked about, so you definitely want to make sure to take a screenshot for this because you are going to need this for your SBW. Okay, so just a hint, 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 you need to use this. If we ask you to describe the meaning of a postulate or theorem, these provide those descriptions: angle, side, angle, and angle, angle, side. For angle, side, angle, you have 2 angles and an included side. For angle, angle, side, you have 2 angles and a non-included side. So really make sure you understand the difference between those 2. Now, let's go ahead and take a look at some actual examples that may be helpful for you as you go into your SBW. So I want my sister to share her sandwich with me, but neither of us want a smaller half than the others, so before we make the cut, we need to be sure they are equal triangles. That seems very fair and very, very, very mature between siblings. Interesting. So based on the triangles below, answer the questions on the following slide. So this is information about the triangles that they've given us, and we want to utilize that information in respect to the following slide. So just keep in mind the diagram at hand. And in fact, what I'll go ahead and do now is make a copy of the actual triangles themselves. And I'm going to go ahead and paste that over here. Actually, it's already over here, so I didn't even have to do that. Perfect. So we have the 2 triangles, and we want to describe information about them. Okay, so I want you to pay very close attention to how this is set up because this will help you on your SBW. It says, determine if the 2 triangles are congruent. Let's start this by breaking the problem down into even pieces. Determine if the 2 triangles are actually congruent to each other. Okay, so I go to my diagram first, and I can see that I can label my triangles. For wherever there's an angle, I'm going to put an A. Wherever there's a side length marked, I'm going to put an S. I have angle, angle, side, angle, angle, side. I have 2 angles. I notice the side is not in between the A's. Notice it's not between the A's for both. That means it's a non-included side. And we have 2 angles. So are the triangles going to be congruent to each other? Yes, the triangles are congruent to each other. We can identify why within the same breath because we know they're congruent to each other. And we know that because of the angle, angle, side, postulate, or theorem. We'll just say the word postulate because we've been using that word a lot. However, some of these are actually theorems. That doesn't matter as much because what matters is what it does more than whether it is a theorem or not. So the abbreviation for this, we want to identify that. It kind of spelled it out already in the diagram. AAS, angle, angle, side. Now the most important part is the meaning. So I will refer back to the slide that referred to this. This was angle, angle, side, right? So that was this slide, right? So in that particular case, the meaning is provided here, right? So in some ways, I'm just going to be a little lazy here, and I'm going to copy this, and I'm going to come down here and paste that in there. That right there is my justification right there, okay? So we have two triangles are congruent if two pairs of corresponding angles and a set of non-included sides are equal. That is exactly my meaning and my justification for this particular problem. All right. So we have the NYE ball gets its shape from 2,688 crystal triangles pieced together. That's fascinatingly geometric. The designer has to be sure that the triangles are exactly equal, or the NYE ball will end up looking like an NYE blob. So based on the triangles below, answer the questions on the following slides. Alrighty, so here we have two triangles, and we have to determine if the two triangles are congruent. We want to name the postulate you use to prove this, include the name of the postulate shortened name, that is the abbreviation, and then we want to talk about the meaning of the postulate, right? So if we look at the two triangles, we can clearly see side, 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 side. And so that means that the two triangles happen to be congruent to each other, all right? Which is exactly what we want to see. They are congruent to each other. Hopefully they are, because otherwise they would have messed up that NYE ball almost certainly. Now, how do I know this? Because of the side, side, side postulate, okay? SSS. That's how I know. The abbreviation is in the name, really. Side, side, side. SSS. So once again, going to my slide that contains SSS, that would be this slide. I'm going to go ahead and use this as my justification, my meaning for my postulate. There we go. I'm going to set it right there. Now, obviously, you're going to want to type that out. Sometimes we'll put if in front. For example, I might say this: if two triangles are congruent, lowercase the two. If two triangles are congruent, well, actually, you know what? We're not going to use the word if because that would be a syntactical error. We don't want to do that. Grammatical error. So we have just two triangles are congruent if all three corresponding sides are equal in length. There is my justification for that particular postulate. And there's another real world example of that postulate. So now let's take a look at the home example. Neighborhood in England is very specific on how the rows of homes need to match. So the architect wants houses to look slightly different but still have all equal looking roof designs. So based on the triangles below, the questions on the following slide, let's figure out whether or not those triangles actually are congruent with just different roof designs. So here's our two triangles. We want to first determine if the triangles are in fact congruent to each other. So we look at the two triangles and we see we have side, angle, side, side, angle, side. You can see the angles are in between the S's. They're included. So that tells us they are congruent. And the reason for that, the postulate for that, we have the side, angle, side, postulate. So that would be SAS. So from there, what we can go ahead and we can do is we can give our justification for why those happen to be congruent to each other. Once again, I can go up to my slides and I can identify the side angle side that's right there. There's my justification for why they happen to be congruent to each other. And I'm going to come down here and select that, paste that in there, and voila, there I go. Okay. All right, so the last example, we have real world bridge example. In order to make a bridge stay level and evenly distribute evenly distribute weight, builders need to make sure the various parts of the structure are congruent. And here is an example of that. Okay, so we have an example here where we have two triangles that are right triangles. So the moment I see that, I'm going to identify wherever there's a leg and a hypotenuse. Here is a hypotenuse, here is a hypotenuse, here is a leg, here is a leg. So the two triangles are congruent. They are congruent. Why? Well, because we have the right hypotenuse leg, right? I'm going to write R because that's how we've titled it in the slides, right hypotenuse leg. Technically, this is actually one of those that's a theorem, but it's okay if you think of it as a postulate, not a huge issue. So sometimes we'll say RHL or just HL, nothing wrong with that. And then we have our slide for HL, which is located right here. And that is my reasoning, my justification. Now, I'm copying it to save time on the video. However, I really want you to think about how you can describe the reasoning. That's the most important part, really. Can you describe the meaning of the theorem or the postulate? You want to write that out and take your time doing that. You want to understand it because you may have to be tested on that in the future. You never know. All right, that's going to be our lesson over 4.06 SBW.